Hello friends, welcome to Civil Engineering exam. Today we are going to see the problem related with design of reinforced concrete elements in the topic of doubly reinforced concrete beam. So the problem is a doubly reinforced concrete beam having the rectangular section 250 mm wide and 540 mm overall depth. This is reinforced with two bars of 12 mm diameter in the compression side and 4 bars of 20 mm diameter in the tension side. So the effective cover to the bar is 40 mm. Using M20 grade concrete and Fe415 steel, estimate the flexural strength of the section using IS 456 2000 code. Okay, so now we have to find out the flexural strength. So now the given data, that is with B equal to 250 mm, so then depth equal to 500 mm. Why? Because the overall depth is 540 mm. So the capital D is given. Again we having the 40 mm of cover thickness. So 540 mm minus 40 mm, that is D equal to 500 mm. Okay, so the capital D equal to 540 mm. So then cover D dash equal to 40 mm. Then FCK equal to 20 Newton per mm square. So then Fy value is 415 Newton per mm square. Okay, so then ASC value, so area of steel in the compression side, so that is 2 numbers of pi by 4 into 12 square. Okay, so that is equal to 226 mm square. Okay, so next area of tension zone, that is AST equal to 4 numbers of 20 mm diabars. Okay, so pi by 4 into 20 square. Okay, so solving this we got the value of 1256 mm square. Okay, so these are all the given values. So now we can find out the moment of resistance mu. So now first step is limiting neutral axis depth. So limiting neutral axis depth, XU limit equal to 0.48 D. Okay, so now 0.48 into D value is 500. So now 240 mm. Okay, so now stress in the compression steel. So we know the formula FSC equal to summation of SC ES equal to 0.0035 into XU limit minus D dash divided by XU limit into ES. Okay, so now we can substitute all the values over here. So now 0.0035 into 240 minus 40 divided by 240 into 2 into 10 power 5. Okay, so now solving this 583 Newton per mm square. Okay, so now this is greater than of 0.87 Fy, that is equal to 0.87 into 415, that is equal to 361 Newton per mm square. Okay, so 361 Newton per mm square is the lesser of 583 Newton per mm square. So now we can provide AST 2, that is equal to FSC into ASC divided by 0.87 Fy. So that is equal to ASC equal to 226 mm square. Okay, so now AST 1 equal to AST minus AST 2. So that is equal to 1256, that is given, minus 226, that is equal to 1030 mm square. So now the actual neutral axis depth. So now the formula 0.36 FCK B into XU equal to 0.87 Fy into AST1. Now we can substitute, so we have to find out the XU value. So now we can substitute 0.87 into Fy value is 415 into AST1 value is 1030 divided by, so this these terms come this side, so that is 0.36 into FCK is 20 into B value is 250. Okay, so now solving this we got the value of 206.6 mm. Okay, so that is less than of XU limit, so that is 240 mm. Okay, so now we can consider this section is under reinforced. So now we can calculate the moment of resistance. So moment of resistance, the formula mu equal to 0.87 Fy AST 1 into D minus 0.42 XU plus FSC into ASC into D minus D dash. Okay, so now we can substitute all the values over here. That is 0.87, Fy value is 415 into AST1 value is 1030 into D value is 500 minus 0.42 into 206.6. Okay, plus, so FSC value is 361 into AAC value is 226 into D value is 500 minus 40. Okay, so solving this we got the value of 191 into 10 power 6 Newton mm. Okay, so now we can convert into kilonewton meter, so that is 191 kilonewton meter. Okay, so this is for 10 power into kilonewton, so now we can put 10 power minus 3, and here mm convert into meter, that is 10 power minus 3. Okay, so now the moment of resistance is 191 kilonewton meter. Okay, so this is a method we can solve the problem. Again we will see next video. Thank you.